Hello everyone, my name is Prakul Balaji and I'm from AP2 batch. This is my innovation as part of the PhD 306 staff, which is adding two numbers using a keyboard interface. So the actual experiment using keyboard interface was just to uh, press the keys on the keyboard and the LCD monitor will display what key we have pressed. So this is sort of an extension to that experiment and just it has two numbers. If, for example, if I press I'll be explaining the aim. So the aim of the experiment is to read two numbers from keyboard interface and display the result of the addition on the LCD monitor as well as store the result in the memory. So the apparatus required for this experiment is a microprocessor, a keyboard interface module, which is ETKB in this case, and a 26-pin flat recording cable. So this is the apparatus as shown. So what does the program do? So this program interfaces the keyboard module with the LCD display uh, and the LCD display with the microprocessor through the 825 chip. It reads two operands entered from the keyboard and stores them in memory location. So operand 1 is stored in 2150 and operand 2 is stored in 2151, and it carries out an addition operation between these two and stores the sum in 215, and it also displays the result on the LCD monitor. So it also implements a delay between the two inputs so that the inputs are not repeated. And yeah, so the program has been divided into several blocks. The first one is the initialize block. This initializes the 825 chip with the keyboard interface module, and it basically sets up the hardware environment. So it reads the first operand, as you can see here, and it stores it in 2150, and it calls the 1133 Hz uh, program, which is basically displaying the data on the LCD monitor. The second block is the delay routine. This takes place after the first operand is read. So this is to avoid a repetition of inputs. So there's a chance that if we press the key on the keyboard, it might detect it multiple times instead of once. So to avoid it, we sort of create a delay to prevent it. So the third block is the second operand input, which is same as reading the first operand. So it reads the operand from the keyboard, it stores it in 2151, and it calls the display program. So the next block is basically addition. So it loads the both the operands from the memory, and it adds them and stores the result in 2152, and it displays the sum as well. So this is the keyboard scan routine. So this program also um, scans the keyboard and waits for a key to be pressed. So, so if whenever it detects a key press, it calls two routines. One is the decoder operation, and one is the found. So the found routine, which is here, it it also temporarily stores the key, the input we get from after the key is pressed. So it temporarily stores it and runs the delay. This is the delay that prevents it from doing multiple times, from detecting multiple things. And the next is the decoder routine. And the purpose of this routine is to decode what key is pressed. Because once a key is pressed, it sends an input to the microprocessor, and this routine sorts of decodes and tries to find out what key was pressed. So this is done by creating a counter, and it sort of rotates the bits and searches for which bit is active, because the input that's sent from the keyboard interface to the microprocessor is a string of bits. So this sorts of this sort of rotates the bits and tries to find which one is active, and we introduce a counter as well. So depending on the count of the counter, we can figure out what key was pressed. And once it's done, it returns back to the necessary operation. So this is the I'll be showing the result video now. Hello everyone, my name is Prakul and I'm from EP2 batch. This is my innovation based on the keyboard interface module. This is the keyboard interface which is connected to the 8085 microprocessor via the flat FRC cable. So my innovation is addition of two numbers using keyboard interface. So let me run the program. So it's executing. So if I press a number, let's say 3. So here it prints 3, and then I press the second number, let's say 5. So it prints 5, and it also prints the sum of these two numbers, which is 8. So the result is printed in the LCD as well, and apart from that it gets stored in the address as well. Let me show it. So if I stop the execution, and it gets stored in 2150H. So if I run it, so this is the first operand, 3, and at 2151 it's the second operand, which is 5, and at 2152 the result is stored, which is 8. So let's try for another example. So if I skip, yeah, so if I run the program again, so this time let's try something different. 4, here 4 is printed, and next if I press, let's say 7, and the result is in decimal it's 11, which means it's 0b in hexadecimal. So if I check the memory address M2150, this is the first operand, this is the second operand, and this is the result. So yeah, thank you. So this was the result, and over here you might have observed that I didn't use the plus symbol which is there on the keyboard. This is because I'm implementing only one operation, so it was sort of not mandatory for me to use it. But if in case we want to use all the four operations which is there on the keyboard, so in that case we would require a plus sign as well. So we have to write a separate code which sort of um, detects which operation we want to do. So yeah, that could be a sort of an extension to this, and a more advanced extension could be using the DMAS code. Like instead of a single operation, we could have multiple operations. Like for example, 3 + 5 - 2 divided by 2. So this is something that requires a more advanced sort of code, because we have to note down the operator precedence as well, and perform the operation based on that. So, but this is my innovation. I've restricted it to addition only, and this could be extended in the future. Thank you.